Hi, and welcome to our fourth lesson in Chapter 2 on polynomials. Today we're going to cover an important topic, dividing polynomials. The reason I say important is because not every polynomial equation can be factored. I wish they could, but they can't. And before we look at other solution methods, we have to be able to divide a polynomial to determine if something goes into it evenly. As in any division, if there's not a remainder, it knows that you know that you divided by something that divides evenly, okay? And that's what we're looking for. I want to remind you of the box method that you maybe did this with in Algebra 2. And using the box method to divide kind of involves working a little bit backward. We're going to divide x squared plus 14x plus 45 by this thing, x plus 9, which we hope might be a factor. Okay, if it's a factor, it divides in evenly. But anyway, to set the division up, we're going to get that x squared right there. The first term, we know we have to get that. We're dividing by x plus 9. I'm going to put the plus right there. And now we got to think backward here. If this is x squared and it comes from multiplying x times something, well, the something up there has to be the x. X times x is the only way you get x squared. Now you multiply your way through the box. X times 9 is 9x. You think to yourself, okay, I have 9x, but this thing says that I need 14x. So I got to add some more x's in there. In fact, I need 5 more, because now when I add on the diagonal, I'm good to go. All right, now we're back to a division step. If this is x and we need 5x, then this must be a plus 5 right here. It's the only way, 5 times x, that you can get that. Then you multiply down. 5 times 9 is 45. And is that what we were supposed to get for a constant? So we divided, and x plus 5 is indeed a factor of this quadratic. Now I'm going to ask you to try it with a slightly tougher problem. I'm going to set this guy up, and let's see, boy, I'm not drawing very straight lines. I need 2x to the third, so that has to be right here. I'm dividing by x minus 3. And now I'm going to ask you to pause the video and do this division. Okay, here's my division. I came up with an answer of 2x squared plus 3x minus 2 with a remainder of 1. Down here I came up with positive 6, but I was supposed to get to positive 7. It would take 1 to get there, so I have a remainder of 1. I'd like us to try that same problem now using a different method. This is called synthetic division, and some folks like synthetic division real well. You may have used this in your Algebra 2 class, but I'm not sure that everyone did. There's a plan over here for dividing synthetically, and it says start out by listing the coefficients in descending order. So 2, negative 3, negative 11, and 7. It says, oh, by the way, in synthetic division, you don't divide by a factor, you divide by what you think might be the root. Remember, in our example we were dividing by x minus 3. The root that would be associated with that is x equals 3. So we use 3 as the divisor here. The second step in the plan says drop the first coefficient and then multiply. I usually do a little box right here, and I'm going to do that. Drop the first coefficient, 2. Now it says multiply. 3 times 2, 6. Next step, add the product to the next coefficient. So we're talking negative 3 plus 6, which is 3. Repeat the multiply and add until you get to the end. So we come here and say 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6, and we have a remainder of 1. Let me just say this. In synthetic division, You may wonder what these numbers mean. So they're the coefficients of what we had when we did that polynomial, the box method division just a moment ago. We were at x to the third. We're dividing by 1 power of x. That means that now our leading coefficient is squared. So we dropped down 1 because we divided by a power of x. 2x squared plus 3x minus 2 with a remainder of 1. And that's exactly what we got before. You should check it. I like the synthetic division. I know that not everybody has to like things my way, but I would like you to try it. We're going to divide this cubic by x plus 2. Please do take care. There is no x squared term in this, so you have to put a 0 in there for it. You are dividing by, here's the divisor, so in your synthetic division, you have to divide by the root associated with this. So the value of x that would take to make this equal 0 is -2. So let's set up our division right here. First coefficient is 1, then it's the x squared term, which doesn't exist, so we got to put a 0 there. Then it's a -7, then it's a -6. We are dividing by -2. And now it's time for you to apply the plan. Okay, let's pause the video and give it a try. Here's my work. I dropped the coefficient, I multiplied -2 times 1, I add, I multiply 4, got added and got -3, multiplied and got +6, came up with a remainder of 0, which is important because that means that that thing we divided by goes in evenly, or that x plus 2 is a factor of this thing. Now, one thing that's important for us to know, if we know one factor and then we get down to a squared, now it's possible that we'll be able to factor this. Okay? They don't ask us to here, but all right, I'd like us to solidify just a little bit what we've been talking about. The remainder theorem says if a polynomial f of x is divided by some binomial x minus some number, then the remainder is f at c. Now that needs some wordage. If we divide a polynomial by some possible factor, the remainder that you get is the value of the function when x is c. The value of the function when x is c. And ladies and gentlemen, that's kind of neat because in the last one we did, we got a remainder of 0. The remainder theorem tells us that the value of the function at -2 is 0, so -2 is a root, and that's important. Okay? That's really important. I'd like you to think about this, please. We've got a polynomial here, a cubic. We want to know if x plus 4 is a factor. If it's not, it says give us the value of the function at -4. Well, we can do that really easily by doing some synthetic division or box method if that's your choice. Will you pause the video and let's try this one. Here's my work. Here's my division. If I'm trying to see if x plus 4 is a factor, I synthetically divide by -4. I do the drop, multiply, add until I get to the end. And you guys, I got a -105 at the end. So x plus 4 is not a factor of this polynomial, but the value of the function at -4 is -105. Okay, that's what the remainder theorem is all about. If we had gotten a 0, that would mean that x plus 4 is a factor. The factor theorem says if f of x is a polynomial function, then if f of x is divided by x minus c and the remainder is 0, then x minus c is a factor of the polynomial. Really, it's just what we set up there, just a little bit different words. if f of x is divided by x minus c and the remainder is not 0, then x minus c is not a factor. Very good. So let's pull it together. I want you to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that negative 1 is a 0. So we know a 0. Oh, by the way, this is a cubic. We should come up with 3 answers. We've given you 1, so you're going to have to find 2 more. Okay, let's pause the video, do some work, and solve that equation. Here's my work. I did the division by negative 1 so that I could get that, they call it the depressed polynomial. I have the coefficients of a quadratic here, 15x squared minus 1x minus 2. Now I solve that by either factoring or quadratic formula if necessary, but this one happened to factor. I did the x box. I needed things that multiplied to make negative 30, but added to make negative 1, and that would be negative 6 and 5. I had in my box already a 15x squared and a minus 2. Those guys go in there. Then the two numbers that you just came up with in the x, negative 6x and a 5x. Then it's pulling greatest common factors out. I have the factor 3x plus 1. I set it equal to 0 and came up with the x of negative 1/3. I had a factor 5x minus 2. I set it equal to 0 and came up with that 2/5. Ladies and gentlemen, this is an important lesson here. Solving cubic equations, polynomial equations, by some method other than looking at a graphing calculator is big stuff. So we'll talk about this more in school tomorrow.